I guess we can start and perhaps identify some, if there are potential
Okay.
Yeah, sorry, there's some noise that I don't know even what it is right now in my background. But I guess we can start with the questions that we've identified and see if there's any room for further meetings and discussions following up on that. But so some of the things that we pose as questions are, how do data generators communicate with the data coordinating centers on metadata attributes that are important to describe particular types of data? Another one is how do data consumers and users communicate with DCC on the important attributes for their needs? And then what are the minimal metadata attributes that are serving both the data generators and consumers use cases? And the fourth one was, well, given all of that information, can we reduce the burden to the users? So yeah, I think we can start with the first one. It would be great if people can share their ideas on that, or what if they have set up these types of communication before with respect to metadata, and what are their lessons learned or positives.
I want to make clear that I'm not saying that people don't have responsibilities and that we shouldn't require to have, and maybe calling it burden is putting too much of a negative connotation on it. I mean, what we're talking about is something that is unquestionably should be part of people's jobs, right? I mean, I put it in, when you learn to be a scientist, your burden is when you write a scientific paper that you do introduction, materials and methods, results, discussion, or whatever the current structure is. You just learn that. Whether anyone regards that, I think people do regard that as a burden sometimes, but that's just the accepted convention of what you do. So I wasn't saying that we shouldn't have those things. It's a question of getting the right balance on what they should be.
Yep, that's a good point.
Yeah, I think people probably understand that. I know here a lot of people are willing to sort of put in the method sections, but don't want to, have 100 different ways of explaining the same thing, and 99 of which they feel are unnecessary. But the one they feel is necessary, people are always willing to include.
But the thing I loved about that example that I showed, where they put that supplemental data in, nobody had to coerce them to do it. I don't think. I would be interested to go back and talk to them and say, well, was that extra work or was it something you'd have done anyway?
Well, I think that's the main issue, that a lot of labs are already doing that type of work. And so if there is a way to standardize it to an extent that fits with what they're already doing, then that would be great. And so, yeah, if we can come up with a process for that type of standardization, in taking the input of these labs into account, I think that would be a really good outcome. Similar to other standardizing body, I mean, it is a bureaucracy in some way, and not the most interesting thing to set up. But if we look at ANSI or the W3C or other standardizing bodies that exist and have produced great results, actually, it might be a case for setting something like that with respect to at least atlases, right? Like setting some form of process for defining the standards that are aligned with what labs are already doing, and using that process to come up with the standards that people will feel are necessary and are not burden. But yeah, that's an example from HTAN is the request for comments process. But I'm not sure if that's the best way to go about it, or if people have other experiences in defining these kinds of standards, or for metadata, or for APIs, or for software. Because I think we can treat metadata as API in like a very fundamental way.
I mean, I think something that comes out.
So there are
it might be.
Sorry.
There are standards organizations, global standards organizations that have SOPs and established balloting processes. I mean, we can look to those to understand how they work and adopt what makes the most sense for this group. I mean, we don't have to make it all up, right? And I was just going to add that part of the puzzle, there's developing the standards, but then there's putting them out there into the community, and that takes education and training and communication. That's a different part of the puzzle to solve. So there's the people need to know they're there, and they need to know how to use them, and they'll want to know who else is using them so that they can get on the bandwagon too, so that they know that they're all using common standards and working with the same goal. So that's another thing that I think needs to be developed and there needs to be some effort put into that as well.
So I think there's another string to our bow as well that we aren't yet talking about, which is that it's to do with tools. And I think if people have the right tools, then it's easier for people to do this. You see, I think one of the mistakes that was made way back was the story with MageML, markup language, and well, the idea was there that we're going to have scientists produce XML, or actually that wasn't really the intent, but that's kind of what happened. People were told to produce XML, but they didn't have the tooling to be able to do it. But I mean, a lot of people, I think the discussion so far was still asking people who were doing work in labs to think about standards. They're not thinking about that. They're thinking about the work that they have to do day to day and getting on with it. And so how can the tools that they're using support it? Let me give an illustrative example. Pretty much everybody, I don't know, there's a large number of people who are writing XML and they don't even know it. They use Microsoft Word. The file that gets saved is an XML file in a certain dialect of XML. They're using a standard, couple of different levels of standards, and that gets created, but they're using Microsoft Word. So we have some tools that do, okay, so it's a jump from there to where we are and what we're talking about. We're talking about much more specialized tools for what we're doing, but there are some tools that begin to do these kinds of things. The ISATab tools, for example, do this. And other tool sets, you know, like it. We've kind of got to make the standard, the issue of the standard, I mean, one of the other strings to our bow is making the standards disappear and make it easier for people to do this by default. Our difficulty is that when we get together, we're a lot of standards people. So if we see a nail, we think we're a hammer, our solution is standards. But we need to be thinking about being tool providers as well that make use of those standards easier.
Yep, a lot of great points, both on the engaging with the community and also the tooling around standards. And I do agree, if there is a really good tool that makes it much easier to analyze certain types of data, and it's utilizing a particular standard, or if there's a great tool that lets you upload certain kinds of data sets so that you're basically going from assay development to dataset and metadata upload within a single workflow, then people would definitely adopt these standards much more readily.
I would frame it slightly differently than saying these are standards tools. These are tools which help somebody do their day-to-day work.
Yeah, true. Yep.
Right?
Yep.
Which use standards. What do I use day-to-day? In line, I might use Excel. So look, an example of a tool like this, which was specifically for this purpose, besides ISATab, was Writefield, which is something that Carol Gogel's group in Manchester had developed. What that lets you do is use Excel to produce semantically annotated descriptions of scientific experiments.
Mm-hmm. Yep, and that's kind of where we're gearing towards within HTAN, where we are not going to expose the standards or the particular formats that we use to store metadata, but they are powering a user interface that's, let's say, a Google Sheet or a spreadsheet that people can fill in much more easily. And so actually, I might take a look into Writefield to see if we can utilize it. If you can share a link, that would be great.
One thing that I know that we do in HTAN, which I think is a useful consideration, is thinking about sort of minimum fields that are required, and then optional fields that might be filled in, and then how do we determine in which cases the optional fields are sort of expected and which fields, you know, they're not expected. And then I guess the other thing that I think we need to be clear about is exactly what is the purpose of the annotation that we're submitting. Is it, you know, each of the consortia presumably has some sort of data model. They already have information that's being submitted. Are we talking about a minimum standard in order to be able to exchange, for example, RNA-seq data across the different consortia? And if that's the case, I'd imagine that the requirements are going to be somewhat different than the standards that are within consortia. So I think it's useful to just be specific about the particular domain that we're discussing.
Yep.
So that would be covered in a tool like Writefield by you would use the specific ontologies for the field or the specific templates for the field that you're talking about. Would be a template in there. And that would be the domain of the experts in that technology to agree amongst themselves about what it should be. And then that would be available as a tool in as a resource in things like ISATab, Writefield, etc. I put the link for Writefield in the chat.
So is it a part of the mission of this consortia or this whole project to develop tooling, or to develop the standards and then get vendors who make tools on board with adopting the standards?
I would suggest it's to solve the problem, and we don't confine it to either of those two things. It should involve, I mean, we should certainly leave it open for other people to create things that don't exist. And that would be absolutely not part of what the consortium does. But to exemplify it and to provide illustrative examples, because if you don't do that, you just end up with something that leaves scientists high and dry without having to do it. I think we have to take it beyond that to make it easy for them to do. And where such tools like this exist, I don't think that's hard. It's not like we need to do this de novo because they don't exist. It's to make use of them perhaps where they do.
But I feel like there are some somewhat independent problems. One is getting people in the consortia to even agree on, you know, what's important and what isn't. And then the one in terms of tools is, you could imagine putting anything you want into a tool. The tool would accept it. So that the sort of way of easily putting data into a tool is sort of independent from what actually gets put into that tool. And maybe you can link them by only allowing certain entries in certain ways, that kind of a thing. But I could imagine it either being tied together or being treated independently.
They are separate. I mean, here's the connection. I mean, the tool has to be using a standard. So if a group goes off and does the RNA-seq thing, in order for that to be consumable by the tool, it has to be readable in this other standard. And we don't have to invent these, they exist. We're just not maybe identifying them and identifying. So that's, you know, right field, I mean, if you read what it says on there, it's an open source tool for adding ontology term selection to Excel spreadsheets. It doesn't create the ontologies. If you've got an ontology for RNA-seq, you would use that.
So in our case, we often, there doesn't exist an ontology for any of the stuff that we need to do.
Right.
So that's
well, yeah, that's
where
great.
We're
you get to create it.
Yeah, but they are, I think what they are, maybe there is not a specific ontology that you need at the moment, but there are ontology that can cover some of the things you want to cover, and maybe you just need to link those different domain ontology terms to create what is your representation of whatever data you're trying. So, I mean, what I've done, I started done it with LangMap was exactly on the RNA-seq data. And one of the problems was we wanted to use ontology to create a way for then the user of the website to upload their data and trying to use ontological terms. Meanwhile, they were uploading the data, but they were not an ontology RNA-seq that was linking all the processing going from the sample to the data analysis. And so what I start doing is trying to create this, what I call application ontology, to link this type of information at the general level. And that's most of them, the term came from non-ontology. So, they came from the ontology of biobanking to the cell ontology, protein ontology, information artifact ontology, OB ontology, ontology biomedical investigation. All the terms were there, but they were as domain terms. And what I needed to do is just grab the single term that I needed and put together with another term from another ontology, following the same rules, and create something that is new. It's like really grabbing words to create a phrase. But you have already most of the term there that you don't need to recreate. You just need to restructure in order to represent what you need.
Yep. And I can sympathize with that experience with HTAM for sure, where you don't have ontologies that cover everything. So you kind of have to create a data model that's tailored by mixing and matching various pieces of ontologies. And I think what became very quickly apparent is that having a process for mixing and matching ontologies in a structured way, having a good format that allows you to do that was important. So I would throw out the words that we use, what we use there, but schema.org and JSON LD, they allow you to kind of reference various terms that are across different ontologies and map from one to the other and put things together in a more coherent way. But this type of strategy of creating a particular data model that's utilizing various already existing ontologies was definitely useful. And tools like Writefield or others that can turn a data model like that into a interface, I think that type of approach is definitely something that can be beneficial. And the question is, can a consortium or number of consortia agree on the approach for mixing and matching ontologies so that downstream tools like Writefield can easily get these tailored data models and turn them into something useful for the researchers that's not requiring the researchers to know how did we do the mixing and matching, which ontologies did we use, and so on. Similarly to the way Excel hides all sorts of XML, ODS type of whatever data standard they use in the background, it's hidden from the end user.
So we
Well,
had
and I would say the other opportunity, I was going to say the other opportunity here is to build out terminology, ontology in a space that has not yet been defined or not well defined, so that you have more common vocabulary to share.
I mean, the other part of this, I mean, and the reference that Milen's making to models, I think is an important one. I mean, it doesn't always come out, but I mean, many of you may know that at NCI, we have the semantic infrastructure. And there are two parts. I mean, well, there's lots of parts, but at a high level, there's kind of two parts to it. One is to do with terminologies, and the other is, I'm going to simplify it, essentially to do with models. I mean, it deals with common data elements, but it also deals with models, and you need both parts. And I think this sometimes gets lost, is that we need both the models and the ontologies. And some of the problems we're trying to deal with are better dealt with by the models rather than the ontologies. And I think the models deal with this provenance question. So to give an example, we might have an ontology for what blood pressure is. But if we think about a study which goes on over time, where blood pressures are taken at many points, and this is to this question that was talked about earlier about time courses, and saying that time courses are part of this context thing. What you want is the data model that says we had these time points on this study and blood pressure was taken at each of them. So we don't want an ontology that says this is the blood pressure at 30 days. This is the blood pressure at 60 days. What you want is a model that says we took measurements, and we took a whole slew of them, actually. We took blood pressure, we did ECG, we did clinical chemistry, and whatever else we did at 30 days. And then at 60 days, we did the same things. And then 90 days, we did the same things plus this other test. And so the combination of the two things gives you the semantics that you need.
So just to, well, I think somebody else was trying to talk when I started earlier, but I mean, just as a point to that, we are for clinical trials, we already have a model for that, for example. So I would hope that people would go look at that and use other global models and approaches that have already been solved and build off that. But again, this is another reason for collaborating and looking beyond the scope of this project and see what else exists out there when defining the necessary metadata schemas and ontologies that are relevant for this community.
Yeah, I was going to say along the same lines. One thing that in terms of how to communicate with the data centers, we had a collaboration with CZI on the project, and we basically just emailed them like a list of kind of what the metadata is and what the kind of definitions of those metadata, and then they had, I forgot what they would call them, data processors or something specific people dedicated to working with us to try and match up the different metadata columns we had with what was already in their system or add new things in their system as needed. I don't know how realistic that is in many consortia, but the concept of sort of everyone emailing things to get to one place with definitions and trying to have people dedicated to combining them, I think is a good one.
Yeah, this type of aggregating.
Go ahead.
Oh, sorry. yeah, like this type of idea for aggregating inputs from multiple institutions, where whether it's more formalized in requests for comments or some standardization, or whether it's emails and they do the job of the data processors do the job of the harmonization and then getting back to you something that the participating institutions will be happy to provide as metadata later on. Yeah, this is yeah, one important characteristics of what we talked about. But then going back to data models, I mean, I think the link here is that this type of aggregated information from institutions will inform the data model, the specific data model that we would like to be using. And say, for example, when we're talking about clinical trials, the particular data model that's used for clinical trials, what would be some of the impedance for reusing that for clinical data across consortia? Like, what are the reasons that people, if it already exists, why don't we just adopt it? Are there certain shortcomings that people have seen, or?
The kind of model that Melissa's talking about
I think
is a general model which doesn't in general cover the provenance problem. So there's part of it which is static. The thing that we're talking about, and we were talking more about it in the other session this morning, about the provenance part. The provenance part is the thing that's specific to a particular study. And that, in a way, and I know some people don't like this, is saying that every study has a different data model. What that means is that every study has a different study design. Not every study is recording blood pressure at 30 days, 60 days, and 90 days. So there's a level at which some of those models have general applicability. And so, for example, that would be in something that says you have the idea of a protocol and you have subjects who are registered to the protocol and so on. But as far as the data that's actually collected on it and the design of the study, that's specific to the study. So it's kind of a somewhat, it's kind of a mixed model, and it's important not to lose that. There are static parts of it and there's stuff that's study specific.
So to be specific, we have, so the FDA requires for submission for all drug applications, information that is in a model that is used, well, it's used globally. It's based in the bridge model, which is a conceptual model. So it's a backbone, but it's not a model that you would use to actually collect or manage data. But the CDISC standards, we have a standard for the protocol, and what it does is it doesn't say every flu study must have this exact design, but what it says is here are the components of a design, and here is where you slot the information so that you always can find it in the same place. So that you have your own data, right? But you just have common metadata and common structures and relations. We have a model for data collection, for data aggregation, for analysis, and then if you were to submit the whole package. We have one for that, and we have data exchange standards. Now the FHIR resources, the HL7 FHIR, FHIR, if you're not familiar with that, is used in EMRs or EHRs, and it covers a wider range of what people call clinical data, because a subset of that would go into clinical research studies. So that's another source of a global model. The biospecimen data there's some information for biospecimens. It's not quite as mature in the CDISC standards, but there are other standards for biospecimen information, and we're looking to use those for the Cancer Research Data Commons. So there's a lot of content out there. Some of it needs to be knit together, as we're saying. But for data that's well defined and everybody agrees, like blood pressure, and until somebody comes up with a different expression of it, those are well-defined standards. You know, I think that there's a lot of content in this space that has yet to be defined, whether it's a formal model or whether it's a vocabulary or a more complex ontology. And there's an opportunity there to build out common shared data concepts, metadata concepts. So, but I do think it's really worth looking into all the existing global standards and commonly used standards and working towards using common semantics, because otherwise we're all just going to keep diverging, and that joke cartoon about aren't standards wonderful, let's build another one, just becomes more of a reality. So yeah, and I think that's definitely, I mean, a lot of important points there. But then why do people or people on the call think that different consortia are opting to reinvent the wheel, essentially? Is there a certain barrier that existing global models are imposing? Is it like a learning curve, or are there political reasons for not adopting one versus another, whatever political means? Well, I do think part of it is just awareness. So there's that education, training, you know, information sharing. I think that's a big component. You know, people who are in the scientific realm are probably not aware of what's used in clinical trials unless they're actually deep into like preparing data for biopharmaceutical companies where they may perhaps have been asked to use them, or maybe they're using them and they don't know it because now it's just a standard way of operating. You know, we have gotten somewhat past that hurdle in the biotech and pharmaceutical industry, that now people have changed over their systems to using them, so it's not. But they don't make a big point about saying what they are, because it's just part of how they work. So I think part of it is just knowledge, and awareness. I mean, I think for all these things, everybody has to figure out how to implement them into their systems, and the way that people choose to implement them can be different from one instance to the next, and that becomes a bit of a barrier to actually making them work seamlessly. Like somebody mentioned the EPIC earlier, the electronic health record system. I mean, part of what I think happens in that community is that the standards may be implemented differently from one implementation to the next, and so then it becomes a bit of a bear to try to actually pull data together. But you know, there can be best practices around how to adopt them and how they're working well. And you can have projects where you test out different implementations and show what works and where some of the hurdles are.
Mm-hmm. Can I give just a really simple use case? There's, say, 3 different people or 3 different groups that are all doing some human study, it doesn't matter what. And they want to code whether which subjects are male versus female. And the first group submits that that they have 2 separate genders, one is M, one is F. The other group submits they have 2 different biological sexes, one is male and female with lowercase letters, and the other group has 2 different sexes that are male and female with uppercase letters. What is the best way of either making sure that the submissions are all in the same format, or collecting that in such a way that it's either the system can figure out that they're all the same, or that we don't have to spend like hours and hours tracking all these things down and coming up with the different combinations. Maybe some of these existing things that we're talking about have that already and I'm just not aware of it. But but I think that kind of level of metadata agreement is something that a lot of people that we work with are sort of get hung up on.
Well, that of course is the classic example, and I think we've all been there trying to sort out if you get data without any data dictionary, what are those zeros and ones and twos and who else, whatever else people code to. I know I've been there. But the CDIS standards have sorted that out, and the FHIR resources have sorted that out. So, you know, there are established conventions now. I mean, if you've collected your data a different way, then you need to map to them, and you could have standard mapping. But
to be clear, which piece they've sorted out, Melissa? When you say they've sorted it out, I mean, do you mean that they've reached consensus that everyone's going to use MNF, or are you talking?
Sorry, you're breaking up a little bit. Sorry, you were breaking up a little bit.
Yeah, can you hear me now? Can you hear me?
Yes,
okay?
Thank you.
Yep.
So what I was saying, I mean, I was asking when you say they've sorted that out, I was asking if you could be a bit more specific about what they've sorted out. So for example, getting agreement about that it's M and F we're going to use, or 1 and 2.
So if you look at in the NCI thesaurus and look for the code list that CDIS has for, well, unfortunately they call it gender because of US guidelines, but
yeah,
anyway, we won't go down that path, but there is a code list, and it has the values that are expected for submission to, and so it says, and they all, because the FDA still uses SAS version 5, they're all in uppercase unless they really need to be mixed case, and they have specifically the terms male and female, and they have synonyms as well. So if you want to use M and F as a synonym, you can do that. But it's all, we have that all in the NCI thesaurus. All the CDIS terminology lives there.
Yeah, and well, you know,
that's always. Sorry.
So
I'm
somewhat familiar with those, and so, but I wanted to understand specifically what you're referring to in that. And so it's the use of, yeah, I point to a particular standard and say, use this for coding of gender. And I think we have some ability to use those standards in certain situations. There's another angle to that though, which is, and I know the topic of pre and post coordination got posted up earlier in the session today, but I think this is an example of it. I mean, the other thing that's actually not as hard to do, I mean, and I think the key thing you mentioned, Melissa, is data dictionaries. And if we've got the data dictionary, and if we've got a machine readable data dictionary, it's not actually that hard, and we've got examples of showing it. Saying, I've encountered this data set done by these people who didn't use a standard, and guess what? They used 2 and 1 for male and female rather than 1 and 2. But it's quite a simple thing to do if I have that data dictionary, if I'm creating the merged data set. And we've got good examples of this, is where we can just say, okay, that's what they did. Here's the translation. And then as a data analyst, you just get on with the work. And we don't have to pay a big data coordination center a lot of money to go and harmonize that data. So those kinds of tools, and you know, as you know, Melissa, mappings are part of what NCI thesaurus does. And so making those available to scientists in a tractable way can also help this.
Well, there will always be the need for mapping, it's true, but the more that you can push the data standardization back to the beginning of the formation of the data, the easier it's going to be for everybody to have visibility into their data and to share data. Share as, not as in data privacy, but share as in be able to actually share the actual content of their data with each other. So, you know, people make their livings off, you know, mapping data. It's big business in the pharma world. you know, we could make a lot of progress if we could try to move towards minimizing that.
I absolutely, no, I completely understand, but I think there are a number of strategies we need to use, and that one's probably not going to go away. And it's easier to do than it might seem sometimes.
But to get back to Milen's question, why don't people use them? I think, you know, a lot of it is awareness and possibility and understanding the opportunity, and you know, a huge project like this is a great way to promote the value of standardizing your data and using shared semantics.
Yeah, that makes sense. And yeah, I think the translation part of it downstream, that's a whole separate loose end that we can tackle. But what you mentioned in the beginning of, like, when you were highlighting why people are not using it, one barrier you mentioned was implementation, where people would have to decide how to implement these models in their systems. And some of their systems are already existing, so they would have to rewrite or refactor them in some ways. And it almost feels that that's probably after awareness, I mean, this is probably the biggest hurdle. And is there anything that the consortia group or cross-consortia group like this can do to provide a set of tools or building blocks for tools that are centered around these models that incentivize people to actually use the models? And that goes back to what Ian was saying earlier, like it's solving everyday problems, but with tools that are centered around these more global data models.
So I'll just throw one more sort of idea in. Last week there was an AMIAN meeting on a technical meeting several days, and the keynote person was from the University of California, San Francisco, and pointed out that even though, you know, like they're a huge system and they had done a lot of work towards standards adoption, they had to bring together two different, like, huge arms of their whole university system. And you know, it took a business reason, he said, to actually unite them across the board. So if, you know, there may not be that business reason, but perhaps there is a reason to publish faster or something, some carrot along those lines that could help bring people to drink from the well.
Yeah.
It might be funding as well, right? If there is funding to bring tools that use specific data models, or there isn't funding to develop your own, then that might be a good incentive. The question is, then we have to be very sure, if there isn't funding to develop your own, we have to be very sure, I guess, that the ones that we have are sufficiently representing the needs and the requirements that the communities have. But okay, yes, yeah, these are definitely good points.
I mean, just to comment about that UC, University of California example, I mean, the driver in that case was healthcare rather than research. And the driver was the quality measures that the US government has said that hospitals need to meet. And so, I mean, a key word here is business, because that's big business. And University of California Health System is highly motivated to do it because of the amount of money involved and so on. The difficulty in research is whether we have drivers of that exert that amount of pressure in order for people to do things. I mean, the grant mechanism is one, but in general, that's a that has much less leverage than the ones that you find in business.
Great. Yep. Yep.
Well, I'm sure this group of people can come up with some incentives that would be appealing across the board.
I mean, I think one incentive is having HCA and Atos and NIH agreeing on, so this will create a lot of momentum for others to follow. So I guess part of this meeting, if we could outline specific steps on how can we agree on at least parts of this problem, whether it's clinical data or biospecimen metadata. And that kind of leads to the use cases where, well, what are the use cases for the data generators? What are the use cases for the data consumers? So we kind of go back the full circle. I guess just a comment to throw out there that there is an opportunity here to actually bring forward some of these standards and create a mechanism to use them in data models and create a mechanism for adopting new standards or developing new standards when there isn't one that's already invented.
I mean, to summarize a couple of the things I'd said, I mean, I would hope that there's somewhere in that the sense of making scientists more productive and helping them do their job, which include, and going in this direction of including tooling to enable that, tooling to make it possible for them to make the standards part of their work. I mean, and in general, that all of this should make it easier for them to do this and to meet them where they are.
So I had, yeah, on that note with tooling, I had a question that might highlight some of the specific problems around that. So for example, if we take right field, and if we ask, can right field take as input the clinical trials data model type of annotation? Is anyone here that can say, yep, that's absolutely possible. We have this tool and it works with that type of data?
I'm going to say in general, it won't.
Mm-hmm.
But what it does do, I mean, from my understanding, it didn't come out of that particular, it didn't come out of the clinical trial regulated research world. It came out of ontologies and data models for the kind of research that HCA and HTAN does, which is more basic research.
Mm-hmm.
And there are models there, and it's based in those models and ontologies.
Yep, yep. So there's definitely some room of connecting tools with existing.
I mean, there was an attempt. I mean, we started out a while back with something which was called the life sciences domain analysis model. You know, and I can see Matt's on the phone, and he and I were texting about Open Specimen earlier. Well, the data model that's in Open Specimen was present in the life sciences domain analysis model, and then it made it into Bridge in some form. So there has been some exchange between these models, but it's not yet completely effective in the way that exchange has been done. It's still a fact, I'm afraid, that the life sciences domain, by which I mean life sciences research, it's quite a different domain with different people in it and different motivations than the clinical trial one. And I think there needs to be some care in trying to smush those together without some respect for the fact that these are different kinds of people. They're all good people, you know, motivated by different things, and we have to respect that.
Well, I think it would be really valuable to go out to, for example, other NIH institutes other than the National Cancer Institute who have already adopted standards and hear about their experiences and their motivations. And then there are other global organizations, I could get you names of some who have adopted standards who are not in the quote unquote clinical trial space, and hear about the value standardized data has brought to their world. I think that there are a lot of people who could talk to the concerns of this particular community and help clarify like what those drivers were that help promote adoption, and the lessons they learned in implementing, and what, you know, so that we don't have to reinvent all those wheels.
Yeah, that's good. And there are some within this community. I mean, it's not like there's an absence of the use of standards within the community we're talking about.
But there's that, I think the question was like, what's the motivator, right? Like, we don't have big business as the motivator.
So the motivator, I'll hypothesize the motivator is being able to do good science, is what the motivator.
Well, right, but how did they effectively motivate their organization to get on board, right, and make the leap? Because I think it was Milen, you mentioned, one of you mentioned, it's a lot of work to change over your systems, and like what made it possible for those organizations to actually implement? Like, and what did it cost, and what value are they deriving from it now that offset those costs in the long run?
I mean, I would draw attention to, I mean, the kind of people, researchers, their alignment in general is not with their organization. It's with their field more than it is with their organization. I mean, that's, you know, the organization is somewhat important, but it seems to me it goes somewhat with the territory that if you're in an academic organization, you're not regulated by your organization in the way that you would be if you were in industry or in government or in other places. Is the best way I can describe it. And that's not a bad thing.
Yeah, it'll be great if we can kind of list some of these organizations Melissa mentioned that can chime in on what did standardization along the lines of biomedical data brought into their institutions, and how did they surmount this type of initial cost of converging on a set of standards, including data models that use those standards. That would be, I think that would be a good next step. I know we have a cross-consortium meeting with HCA and HubMap HTAN. I see Laura Clark is on this call. She's participating in that effort, and
I'm here on behalf of Laura Clark.
okay.
Laura is not available.
Okay, yeah, okay.
But
that's okay.
I am HCA as well.
yeah, no, that's great. And we discuss very similar questions. So, and one of them is this type of standardization, and what would be the incentives and kind of literature review. So it would be a great next step if we can either use that meeting as a forum for future work on it or presentations from people, and also to hash out details that along the lines we've discussed here, like tools and how tools can be built around various data models. So I'm just throwing it out there, and we can have it in the notes. Okay, I think we have only about 7-8 minutes, and there is in the document, and I see, thank you for everyone that's been taking notes. They're very detailed. We have the final template that lists a few items, like problems we think we can solve by collaborating, and recommendations for what we want to do. Names on the consortia that were represented on the call and so forth. And I think we can definitely fill in the various portions that are related to what consortia we had. We have those in the notes. But in terms of the first couple of items, so what are the problems that we think we can solve by collaborating? Is it creating more awareness, which would be great in general, or are there other problems that we can tackle too? Like, for example, this mapping of ecosystem of tools to data models and standards, or something even more specific, like taking a specific data type, like clinical data, and figuring out what are the minimal required attributes related to clinical data that can be relevant to our consortia. And reusing in that process existing global models and making sure we're compatible when we're creating these minimal specifications. So I guess that's something that we can do. And if, yes, feel free to also suggest others, other problems that we can collaborate on. And then, yep. Sorry.
About that minimal list of required fields, I would strongly suggest, given our previous
discussion.
Well, our experience. Yeah.
Oh, experience. Okay.
Experience,
yeah.
To communicate with the community, to involve the community in the creation of that standard, because you might do a lot of, like, there might be a lot of work done, and it might not be as important. Like, you can try and define a standard and then present the standard, but then you probably have done way more work than needed. That makes sense. And and
I think that, I mean, that's a point where in a lot of these cases, there are existing standards that already exist. And so we should probably take advantage of them, because when creating them, during their creation, I'm sure people have had the input of the community. And so they're not probably existing out in thin air on their own. So I think maybe the question is, how do we tailor them to the needs of specific communities, or which portions of them do we adopt that are relevant and that can take the input of the community? But yeah, definitely not trying to reinvent the wheel when we can already use something. But then how do we lower this burden of re-implementing systems that exist? So having the experience of organizations that have done that, I think that might be very valuable. and it might be valuable even for organizations that are just starting building these systems, where it's HubMap or HTAN, so that we avoid errors that others have made in the past. In developing these best practices guides, I think that might be actually pretty useful as part of this awareness. Because I think one of the reasons, specifically for HTAM, we took some time with even some basic, in retrospect, system parts of our system, is that there wasn't really a document that we can go to and that states these are the different components in your system, these are the available standards, and these are the available implementations of these components. Feel free to modify them for your needs, right? There wasn't anything in that type of centralized resource or pointers to other resources. So we had to look at what other consortia has been done, like HCA, and get some of their methods and invent some of our own methods. So definitely I think best practices document would be, or whether it's a document or a site or some form of resource would be great. And I feel like HubMap have probably experienced a similar kind of roadmap where it's hard to navigate what are the needs for data coordination and data model standardization and so on. I'll stop here because I okay, unless there are other comments, I think we have 5 more minutes. We can either conclude, and I can go over also if people that were scribing, again, thanks to everyone. But if people that were scribing or taking notes, if we could organize this document and represent what we want in the blue box so that we can share it and we make sure that we haven't missed anything, that would be great.
I would encourage people to read over at least the green box. I was doing my best to put things in the correct spot, but a lot of the comments I really wasn't sure where they fit, or they didn't really fit on any of the themes we had, or I may have put them in the wrong place. So.
No, that's great. I'll for sure be going. But true. Yep. Sorry.
I'm sorry. I would just say from the last session, I mean, as a moderator, like we were asked in the blue box at the bottom of the document, that's what's going to be shared publicly. So to make sure, maybe it would take a couple of minutes just to make sure that says what we want to share out. Because we can always come back. People won't see what's in the green box. They'll see what's in the blue box at the bottom of the document.
Yeah, that makes sense. Does anyone in the meeting know when this blue box is due? Is it immediately after the meeting, so that I just adjust my time, like make some time to fill it in before?
I don't know. We did it at the end of the meeting, so it was done.
Oh, okay. Okay.
Yeah.
Yeah. Okay.
I'm not sure.
And I see that there's already some information in it.
It's just a first cut, so make sure it reads the way you want it to read.
Yep, that sounds good. So I'll go over through the comments in the green box, and based on all the input that we had in the meeting, we'll summarize it in the blue box over the next minutes. And so if everyone can check in like in half an hour, and they can feel free to then adjust if I missed anything. Everyone who is interested. Because I think we have three more minutes, which might not be enough to actually populate it.
Well, we could at least agree maybe in these 3 minutes on the
Yep.
problem we think we're solving here, that top bit.
Yeah, that's true. Yep.
I like that, making it easier for scientists to do the right thing. Good. Any other thoughts? Not everybody's been so vocal. Maybe somebody who's been quiet has something they want to say.
So, from my own perspective, I work for the HCA DCP as a data wrangler. So basically, I broker the data in. One of the things that I've observed and you've noted down really well is that the tooling is really important. It doesn't matter if your schema it's really good, but if no one knows how to use it, or they have to spend 3 hours, 4 hours, 5 hours learning it, it's not going to be used. So the tooling part, I think it's really important. And
Yep.
also making it easy. So the standard has to be computer readable, but the implementation has to be human readable, if that makes sense. That's one of the things that I have observed working for this.
Yeah.